Assalamualaikum warahmatullahi wabarakatuh, and welcome to a video on explaining how to do integration, which is under the subtopic Differentiation Reversed. So here I am Cikgu Muhammad Afiq and I will be explaining this topic. Alright, so before we start doing the topic itself, so please students try to do the starter. The starter over here is to expand and simplify double bracket 2x minus 1 bracket x plus 5. Please pause the video for 3 minutes and play if you have your answers already. Alright, 3 minutes is up. So please check here. Your final answer for the starter should be 2x squared plus 9x minus 5. Alright, back to today's topic. In this video, the learning objective for this topic is to use integration as the reverse process of differentiation, and also you have to find y in terms of x given the gradient functions dy by dx. So in the steps to success, other than to define integration, you are going to convert gradient functions as a function of y in terms of x using this rule. So if dy by dx is equals to x to the power of n, and then y is equal to 1 over n plus 1, multiply with x to the power of n plus 1 plus c, where c is an arbitrary constant and n must not equal to negative 1. So over here, take note of the change. From the simple x to the power of n, it becomes n plus 1. And there's also multiplication of 1 over n plus 1 over here when you try to convert gradient into y. Alright, now, in the previous chapter, we have learned about process of obtaining dy by dx when we know y. So this process is called differentiation. I believe that you have learned that previously. So this is the rule, just to recap back. But then, if you try to apply two functions of the form y equals to x squared plus c, what we will obtain, where c could be anything. C, it could be a single decimal, it could be plus a number or minus a number, or it could be a blank. So over here, we can notice that if we try to differentiate this, you will get 2x for all of this. But then, for the reverse process, we are going to try to find from 2x, which is dy by dx, into y back. So obviously there, you cannot find this constant. So this constant must be written as plus c, as you see in your steps to success. Because when you have a gradient function, you cannot find c as the constant, right? So, for example, okay, over here, if we look at the basic rule of integration over here, if dy by dx equals to x to the power of n, so that n will be add 1 to it, and then you have to also multiply with 1 over n plus 1. For example, here, if we have dy by dx equals to x to the power of 4, so here, your power is 4. So n equals to 4. So what happens to this n is that you have to add it by 1. So on the left side, dy by dx is changed into y. And then following this formula above, so 1 over 4 plus 1. And then next to it will be x to the power of 4 plus 1. Right? Everything over here plus c. So you will have y equals to 1 over 5 x to the power of 5 plus c. So this is the integration, and c must be always added to this because you can never know what is the arbitrary constant. Alright, turning to the next page over here, for example, find y in terms of x for each of the following. So for part A, you can see there, you must turn the x square root of x into a power function. So here, dy by dx must be changed equals to x to the power of half. So this power half must be changed because you want to use that as our n. So y equals to So following the format of your given formula over here, so 1 over n plus 1. So 1 over half plus 1. So here 1 over half plus 1, and then the x to the power of the power also you need to add it by 1, and next to this it will be plus c. So here if we try to simplify y would be 1 divided by 3 over 2. So 1 divided by 2 over 3 over 2 will be 2 over 3. And then x to the power of 1 plus 1 and a half, it would be 3 over 2 plus c. So this is for part A. The next example is when we have dy by dx equals to 1 over x to the power of 3. So here, we can also change this x to the power of 3 because we cannot integrate this directly. So it has to be in the form of x to the power of n. So dy by dx is equals to x to the power of negative 3. So here, integrating this, dy by dx equals to, will become y, and x to the power of negative 3 would be x to the power of negative 2. Following the format, it is going to be 1 over n plus 1. And next to it will be x to the power of negative 3, also plus 1. So here, don't forget to add c in the end. Therefore, your y would be 1 over negative 2. So it is negative half x to the power of negative 2 plus c. So you can leave your answer like this. But if you want to change to another format, you are most welcome. Right, so that's for part B. Right, let's go to part C onwards. Okay, for part C, over here, dy by dx equals to 6x squared minus 5 over x squared plus 4x. So here you have to change also the second term, which is 5 over x to the power of 2. So dy by dx can actually be written as 6x squared minus 5x to the power of negative 2 plus 4x. Right? So here you have to change this. Right? There's nothing more. So you can already convert the gradient function to y in terms of x. So dy by dx equals to y. And then here, 6x squared, you can actually make into a single fraction, because here, before I start to do the single fraction form, you can actually combine the x power 1 over 2 plus 1. For example, here, you can actually bring it to the numerator of the fraction. So here, for this particular example, I will write down a fraction form first, and then change the power by adding it into 1. So 2 plus 1 is a power 3. So the power will be in the denominator. And then 5x to the power of 2 can also be like this. So negative 2 plus 1 is negative 1. So that means the denominator is negative 1. And then plus 4x. So 4x is 4x power 1. So here it will be plus 4x to the power of 2. Everything here divided by 2. So then don't forget you have a plus c in the end. So here you can actually simplify this. 6x cubed divided by 3 will be 2x to the power of 3. And then negative 5 divided by negative 1 will be positive 5x to the power of negative 1. And 4 divided by 2 will be positive 2x squared plus c. So this is for part C. Alright, let's move on to the next one. The next one is you have to find y in terms of x for this. So this one, for part D, if you look at overall, dy by dx equals to 8x power 3. But then as for this one, you have to change it into 4 over 3 x to the power of 5. If you bring it to the numerator, it will be x to the power of negative 5 minus 2. But then for a constant 2, there is an x actually next to it. It will be x to the power of 0. Right? So here, when you try to integrate this, 8x to the power of 3 plus 1 is a 4 divided by 4, and then minus 4 over 3. Next to it, I will suggest you to write down bracket x to the power of negative 5 plus 1 is negative 4, everything over negative 4, and the 2x to the power of 0 will be 2x to the power of 1, so you can leave it as 2x, and in the end will be plus c. So for this one, therefore, if we try to simplify this, it will be 2x to the power of 4, negative 4 over 3 times negative 1 over 4, the scalar number in front of here. Okay, the coefficient of negative x to the power of 4 is positive 1 over 3, x to the power of negative 4 minus 2x plus c. So this is, for example, D. And next one will be this E. So for a particular example like E, because here you cannot really integrate this directly, so all you need to do is to simplify the x minus 2 over x plus 5, everything over x. So here, let me just write this down back as denominator square root of x is x to the power of half. So here, this one, you have to change this. You have to change this so that you can integrate this easily. Okay, much more simpler. So here, if you try to expand the numerator, x minus 2 bracket x plus 5 bracket, so it will be x squared plus 5x minus 2x will be plus 3x minus 10, and everything here is over x to the power of half. But then here, we can split them up by writing down this as 3 fractions. So the 3 fractions are x power 2 over x to the power of half minus 3x over x to the power of half, and then minus 10 over x to the power of half. This is basic fraction knowledge. So here, then we have to simplify each of the fractions. So x to the power of 2 divided by x to the power of half, you will get x to the power of 3 over 2, and then minus 3x to the power of 1 minus half will be x to the power of half minus 10 power x to the power of negative 2 if we try to bring this up. Right. So here, the derivative for this one, it would be, okay, the dy by dx, the one that you're going to integrate, okay, it would be this function, x to the power of 3 over 2 minus 3x to the power of half minus 10 x to the power of negative half. So here, what we're going to do next is dy by dx will become y equals to x to the power of 3 over 2 plus 1, it will be power 5 over 2. So here, denominator for this one will be 5 over 2 minus 3x to the power of half, power of half plus 1 will be power of 3 over 2. So here, the denominator will be 3 over 2 for this fraction minus 10 x to the power of negative half plus 1, it will be positive half. So the denominator for this one will be positive half, and don't forget to add c in the end of this expression. Alright, so therefore, if we try to simplify this, 1 divided by 5 over 2, it will be 2 over 5 times x to the power of 5 over 2 minus 3 divided by 3 over 2, it would be plus, is this a plus or minus? Okay, let me double check something first. Okay, there's a mistake over here. So this is actually a plus. And yeah, so here everything is a plus. Just to correct this one back. So here plus 3 divided by 3 over 2 will be plus 2x to the power of 3 over 2. And then minus 10 divided by half will be minus 20. Okay, apology for that. Let me correct this one back. Plus C. Right, so this one is the final answer for the example E. Alright, now one of the application that we can do with integration is when you encounter this kind of question. Because sometimes it requires you to integrate because you will be given a gradient function like this. Okay, a gradient function like this, if we integrate it, it will be y. Okay, y is a general subject for any equation of the curve. So for this question, we are going to find the equation of the curve with the subject y. So here, just to read the question back, a curve is such that dy by dx is bracket 1 minus x, bracket 3x minus 2. And the curve passes through a certain point. That certain point is x equals to 2, comma, y equals to 8. So you're going to use this information to find the equation of the curve. So here, we have a step over here that is given to you. Integrate the gradient function first. And then because if you integrate a gradient function, you have a plus c in the end. So that plus c can be determined by using the given point here. So dy by dx over here, let's expand it first. So 1 minus x times 3x minus 2, it will be 1 times negative 3, positive 3x, it will be 3x. And 1 times negative 2, it will be minus 2. And negative x times 3x is negative 3x squared. Negative x times negative 2, it will be positive 2x. So here, if we try to simplify this properly and arrange them, it would be negative 3x squared. And then plus 3x plus 2x will be plus 5x minus 2. So from this one, we will integrate this. Then dy by dx becomes y. And then negative 3x to the power of 2 will be negative 3x to the power of positive 3. Because 2 plus 1 is a 3. Also divide this by 3. Plus 5x power of 1, it will be 5x to the power of 2. Everything divided by 2, and then minus 2 x, because here x is x to the power of 0. Okay, just to recap back. So for any constant, you can actually just include x in the end, and then you have a plus c. So here, this one, if we simplify this before we find the constant, you will have y equals to negative x cubed plus 5 over 2 x squared minus 2x plus c. So here we have to find a constant in order to complete the equation of the curve. So to find c, we have to do substitution. So substitute, what coordinate do we have here? So we have x equals to 2 and y equals to 8. So here, just put it here and move it to the question. Alright, so here substitute 2 and 8 into the above equation. So on the left side, y equals to 8 equals to negative x cubed. Okay, be careful over here. Please make sure that you write down the x inside a bracket, a pair of brackets. So here, negative bracket 2 cubed plus 5 over 2 x squared, same thing. So the 2 will be inside the bracket, outside will be a square, and then 2x is going to be 2 bracket 2 plus c. So here, if we try to simplify this, 8 equals to negative 8 plus 5 over 2 times 4, it will be plus 10 minus 4 plus c. So this one, 8 equals to negative 2 plus c. So therefore, c equals to 10. So there you have it. Therefore, the equation of the curve is going to be y equals to So let's follow what we have previously, negative x cubed plus 5 over 2x squared minus 2x plus the c, which is plus 10. So negative x cubed plus 5 over 2 x squared minus 2x plus the new constant, what we found is plus 10. So this is the final answer for the last example. Alright, so with that, I hope you have completed the notes. So to end the lesson for today, you are going to do plenary. So the plenary over here, I have 2 questions for you. So you say thumbs up if you think that the solution for the following question is true, but if it's false, you have to give thumbs down. So you have 2 questions over here. Find one in terms of x for the following. So for these 2 questions, I will show you the solution. So for question number 1, this is the solution that a student wrote. So in a few moments, okay, please decide whether this is true or false. So for this one, in 5, 4, 3, 2, and 1. Is it true or is it false? So for this question, the solution is false, because here there is a common mistake over here. 10 divided by 5 over 2, the student must get 4 instead of 25. Alright, moving on to the last question for the plenary. Okay, please decide if this is true or false for the solution question number 2. dy by dx equals to 10 over x cubed. Okay, observe the solution. And in 5, 4, 3, 2, and 1. Is this true or is it false? Alright, so for this one, the solution is correct, so it is true. Alright, so with that, that's the end of the lesson for this topic. Alright, so with that, thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh.